our video on wiring. Wiring is a rather unique process that you will face towards the end of your project, but there are many principles in this video that are going to be useful to you at any point during your modeling process. So let's go ahead and get started. In this video, we're going to be recreating this wire that is traveling from our microcontroller up into our GPS unit at the top of our drone. Now I'm going to reuse the sample drone that we've used in previous videos. In this video, however, I've hidden a couple of the major components involved in the fuselage, including the fuselage body and the canopy section here at the front of the drone. And I've also taken a section view of that left side, which is going to allow us to see a little bit more clearly whether or not these wires are actually clashing with that canopy piece that's covering it. But we're going to go ahead and get started without the canopy so that you can see my process here. So let's take a look at how this wire was created. This wire consists of a spline that's moving through a handful of points, moving from the microcontroller on the underside there, up and over, and then up into the GPS unit, and a profile, which we can actually see from the back here, that defines the actual shape of the wiring. Now we need to recreate this wire, so first things first, I need to come in here and delete it. And I'm going to do that by simply deleting this spline. And it's going to ask if I want to delete all children, which is essentially everything that relies on that spline for its definition. I'm going to go ahead and do that, say OK, and that's going to delete the wire as well as the profile. Now the spline was defined by 3 points, and we can look at those now. Those 3 points consist of one drawn on the underside of this microcontroller, one on the underside of the GPS unit, and one in space that's defining a certain point to make sure the wire goes over the edge of this pig's hog. Now this one, if I double click on that, we can see it's simply defined as a set of coordinates in space. And for defining a spline for wiring, that's actually the best method, because this is going to allow me to move this point as much as I need so that I can get that spline exactly how I want it and make sure it passes properly over the microcontroller. Now you could also define a spline with more than 3 points to give you a little bit better control of the path that it follows. But in this video, we're just going to work with these 3 because I want to show you how it's possible to do the same process with only 3 points. So for that point, that's actually the position I wanted in. So I'm just going to leave it at those coordinates. Now the other 2 points that are placed on here are actually part of the definition of each of these individual parts. If I come over here and look in my tree, I can actually find there's the autopilot, and these points are defined as part of the geometry of that autopilot. I can look in the part model here and we see there's an individual point back here, and that point is then duplicated using a symmetry over to this point here, and then there's a second point, this one back here, that they repeated using a rectangular pattern. They then went through and made publications of each of those points so that they would be available as definitions in other parts in our model. And that process is very important because if I have to change anything about this autopilot unit here, if I had to make it somehow thicker or if I had to move it in space, it's going to ensure that these points move with it as it updates the model, which is going to move all of these wires with the part. One note of caution, however, there's nothing in that definition that's going to keep these wires from passing through solid objects after I've moved any one of these parts. So wiring is going to be one of the last things you're going to want to do as part of your model once you're fairly certain of the position of each of these parts, because after I move a part, I'm going to have to go through and check each individual wire and change some of the definitions to make sure they're not running into solid parts. Alright, let's go ahead and let's use these 3 points, however, to define my wire. So first thing I need is I need to make sure that I create a wire part, or wires part, in this model. Now obviously each of these wires represent an individual part associated with this model, but I'm only using this geometry as a representation of where the wires could go, and to ensure that there's enough space in my model to thread those wires through the parts. You'll notice one of these wires actually passes all the way back into my wing here, and I need to make sure there's enough space for that to go all the way back to that servo. So since I don't actually need to create an individual drawing for any of these wires, it's okay for me to keep all of their geometry in one part just to have a representation of where they could be. So I'm going to make sure I activate the geometry for that wires part, and then I need to make sure I'm in generative shape design. Because we're using a spline and passing a surface over that spline, generative shape design is going to be the easiest way to go about this process. Alright, so let's make that spline. So I'm going to make sure I go into wireframe, select spline, and then I'm just going to select those 3 points, and I'm going to go in kind of reverse order here. Because I have some numbers written down that I'm going to use that's going to go in this order. And that's going to define a quick spline. Now splines always take the shortest distance with some allowance to minimize sharp points along that path. So notice it's going to come into both of these points from the top here with this autopilot point, and just from the side here on this. We need to make sure that they go straight up and down into both of these parts. So to do that, I need to come down here, go to Show Parameters, and we need to add in tangent directions to both of these. So I'm just going to select on that field down here on this menu, and then I need to use the XY plane, that horizontal plane there, and it's going to force that point to be normal to the XY plane. Make sure it goes straight up and down at that point, and that looks good right there. I'm going to come up to point 1. I'm going to do the same thing. I'm going to use the XY plane. Now notice it is coming in from the top. We just click on this little arrow here to reverse that direction and force it to come down from the bottom. I'm actually going to add in a tangent direction on this point too. Now this isn't entirely necessary in all cases, but what I'm going to use later in this video is the tangent tension to define what the curvature is of the spline along that point, which I can only do if I add a tangent direction. So I'm going to go ahead and add that. I'm going to use a ZX plane, and I'm going to reverse that direction as well, and just force it to go kind of horizontal in this case, and move down. And we'll come back to the tangent tension and I'll show you what that means a little bit later. Alright, so now we have our spline. It curves up, goes over the top of the autopilot, and then curves up into the GPS system up here. So that looks pretty good. So let's go ahead and move on to adding the actual wire profile. So I need to look at the bottom of this shape here. Now I can actually try to position the sketch directly on the surface here, but I'm going to be a little bit more general. In some cases, that's not going to be an option. So I'm going to add a plane, go through this point, and then what I want to do is change this to normal to curve. I have the point it's going through, and then it needs the curve. It's the spline itself. And that's going to ensure that the profile always stays normal, exactly perpendicular to this curve. Say OK. And we're going to put the sketch for that profile right on here. Alright, so let's go ahead and draw this. Now again, I'm just going to move these circles off and put them off to the side. And the reason I do this is just to make sure I don't accidentally create any additional constraints. So I'm purposefully putting them in to force them to be vertical to each other. But just like how if I move it next to this top circle, it will make them tangent to each other. I just don't want to accidentally force something to be defined relative to that point until I'm ready to do so. Double click on constraint, and I'm just going to add, that's a diameter. And a nice little tool that I haven't shown before, I'm working in millimeters in this case, but I actually have the measurements written down in inches. I can just write in inches as part of my definition, and it will automatically convert that into millimeters in my measurement system. So for each of these, I'm going to include that inches measure. Okay, then I need the distance between each of those. Let's zoom in. These are all forced to be vertical already, so this is going to know that I want the vertical distance between those 2 points. And this one as well. Now I can just quick trim, remove those extra curves. And there's my profile for my actual wire. Now all I have to do is move it into place. So we're going to get off of that tool, select this point, hold Control, select that point, and I'm just going to force them to be coincident. And there we go. Now I can exit that app, and we're ready to create our swept surface. So in Surface, I'm going to go to Sweep, and it's just going to take that profile. I need to select that spline as the guide curve, and that's all I really need to do. This is kind of a frightening dialog box, but we really only need those two selections made, and I can hit OK. And that has created that path for our wire. Now obviously that's not what we want. It cuts into this wire here, and even more clearly cuts through the autopilot there. But I wanted to produce it first so we can actually see what changes when I add some tension to our spline. So let's get back into the spline, and I'm going to show you how that process works with this tangent tension item here. Now again, that essentially defines how tightly it's allowed to curve at each of these points. By adding in some tension, we give the wire a little bit more stiffness so that, for instance, this little turn right here, we can define that to be a little bit smoother of a transition, not so tight of a curve there, because you can actually see here that that surface is kind of bending on itself right there. So I'm going to go through, and again, I have these numbers in front of me, but you would want to experiment with these a little bit and kind of find what works for your case. Now this is just one method of defining how that spline moves. You're also welcome to add some additional points into your spline to make sure it has to pass around something like this autopilot before it can move up through this one. So I'm just going to add each of these. So that is 1.5, 1.9, and now notice when I select past that one, it's going to jump out past, there it goes, jump out past that autopilot. That 1.9 forces it to jump past there because this is the sharpest that I'm allowing it to curve near that point, forcing it to jump out further. And this last one is 2.2. You can hit OK. That forces it to jump a little bit lower. Now we can also see it's curving past that wire, not running into the wire. It's not running into my autopilot. And there's a little bit of maybe an awkward twist near the end here, but not one that's bad. And it goes straight up into that GPS. And now I can even check it. If I jump back down here, I can unhide that canopy. Now there are holes cut for these antennae here, but now by kind of moving this around, I can look at the canopy as well and see that there is some clearance in that canopy, and I'm just fine. More importantly, I can look at the top here and see that none of that wire is visible up here because, again, this is just a representation of where the wires could go. That looks good, so I'm going to hide the canopy again. Alright, now, last part of this process is making it look pretty like these other wires in here. And that's actually a pretty simple process. All I have to do is come in here and select each of these surfaces as part of my profile. And because there's a sharp corner right here, it's only grabbing this one part of the wire instead of the entire thing. I'm going to go to Properties, right-click, go to Properties, and then I can just change this color. There's a reference section and a graphic section. Change this color into what I want. So that one's going to be green. I can hit Apply or OK. Then I'm going to select this other side. We're going to make this one blue. There we go. OK. Now this middle section sometimes is a little bit touchy. Right click on that. Set that to black. And that is the whole process. Now you can see that whole wire going up. Both sides of that curve is black. It's going up and over, plugging in, and that is my wire. And I could come back in and hide this spline and the points, which you notice the splines are hidden on each of these other wires right now. And that's the process. Thanks.